You've seen them, right? Those wild headlines that pop up on your feed about a giant asteroid hurtling towards Earth, threatening to wipe us all out. It feels like every couple of months there's a new doomsday prediction. So today, we're going to cut through all that noise. We're going to separate the Hollywood fantasy from the scientific reality and find out just how prepared we really are. So you're scrolling, and then bam, you see this. A post that makes your heart skip a beat. It's got all the right keywords, NASA warns, planet-sized, and that terrifyingly specific 72% chance. It sounds official, it sounds urgent, and honestly, it's pretty scary. This is the exact kind of claim that's been freaking people out online. So let's just tackle this beast head on. The story that went viral pins the date, July 12th, 2038. That's the day a supposed planet-sized asteroid is set for a catastrophic rendezvous with Earth. I mean, when you read stuff like that, it's hard not to wonder, right? Is that it? Are we just counting down the clock? The short answer? Nope, not even close. That whole story about a 2038 asteroid strike is 100% completely and totally false. So where in the world did that 72% chance number even come from? Well, get this. It came from a NASA drill. They brought together over 100 experts from around the globe for a hypothetical exercise, a practice run, to see how ready we'd be if something like that happened. It was a simulation, not a prediction. Okay, so now that we've thrown the fake news in the trash, let's talk about the real science. What are the actual objects that scientists are keeping an eye on? Let's talk about a very real and, for a while, very famous asteroid named Apophis. When it was discovered back in 2004, the first pass math gave it a 2.7% chance of hitting Earth in 2029. Now that might sound low, but for an object big enough to cause major devastation, it was enough to get everyone's attention. For a time, scientists were worried about something called a gravitational keyhole. The idea was that as it passed by in 2029, Earth's gravity could thread it through this tiny little window in space, setting it on a collision course for a future pass-by. But here's the good news. The more we watched it, the more data we got, and scientists were able to completely rule that out. Today, NASA is confident. Apophis poses zero threat to Earth for at least the next 100 years. And that's how this works in the real world. Space agencies maintain these incredibly detailed risk lists, like this one from the European Space Agency. You can see every known threat is calculated and tracked. At the top of this list is a relatively small object with a 1 in 387 chance. Then you have a much bigger one, but look at the odds, 1 in 4.27 million. It's all about watching, calculating, and refining the data. But why track the small ones? Because size isn't everything. Back in 2013, a meteor only about 20 meters wide, that's smaller than a tennis court, exploded in the sky over Chelyabinsk, Russia. It didn't even hit the ground, but the shock wave it created shattered windows all over the city and injured nearly 1,500 people. It was a huge wake-up call that even the little guys matter. Okay, we've been throwing around a lot of terms: asteroids, comets, meteors. So what are we actually looking for up there? Let's break down the lingo real quick. The big umbrella term for all of this is a near-Earth object, or NEO. The name is pretty self-explanatory, right? It's any asteroid or comet that has an orbit that brings it into our general neighborhood of the solar system. So under that umbrella, you've got two main players: asteroids and comets. Think of asteroids as big chunks of rock and metal, mostly hanging out in the asteroid belt between Mars and Jupiter. Comets are the dramatic cousins from way out of town. They're basically dirty snowballs, ice, rock, and dust from the outer edges of the solar system. When they swing in close to the sun, that ice turns to gas and creates that beautiful, iconic tail. The other huge difference? Comets are moving about twice as fast, which means if one were headed our way, we'd have a lot less time to react. And the names for these things change depending on where they are. It's kind of like their life story. When it's just a chunk floating around in the vacuum of space, it's a meteoroid. If it hits our atmosphere and burns up, creating that beautiful streak of light we call a shooting star, that's a meteor. And if a piece of it is tough enough to survive that fiery journey and actually land on the ground, it gets a new name, a meteorite. Okay, so we know what these things are and where they come from. Now for the most important question. What on Earth are we doing about it? Let's take a look at our planetary defense system. And let me tell you, this is not some guy with a telescope in his backyard.
We have an absolutely incredible network of programs scanning the skies. You've got Linear, which discovers something like 65% of all new asteroids. The Catalina Sky Survey is so good, it once predicted a small asteroid's impact down to the minute, 19 hours before it happened. And then you have systems like Atlas, which is like a final tripwire, scanning the entire night sky twice every single night. So what if we actually find one with our name on it? Well, we have a playbook. The main strategy is called a kinetic impactor. Basically, it's a cosmic game of billiards. We smash a high-speed spacecraft into the asteroid to nudge it onto a new, safer path. There are other ideas too, like a slow push method using gravity or solar energy. And then, of course, there's the last-ditch Hollywood movie option using a nuclear device. But that one is way more complicated and risky than it sounds. Now, the coolest part about that kinetic impactor idea, it's not just a theory anymore. We've actually done it. On September 26, 2022, NASA's DART mission pulled off something straight out of science fiction. They flew a spacecraft millions of miles through space and deliberately crashed it into a small asteroid called Dimorphos. And guess what? It worked. It was a spectacular success. For the first time in human history, we successfully altered the orbit of a celestial body. We proved that our main defense strategy isn't just a plan on a whiteboard, it's a tested, proven technology. So, let's bring this all home. We've busted the myths, we've seen the real threats, and we've looked at the incredible defense systems we have in place. What's the bottom line? Well, remember that NASA exercise that sparked all the fake news? It brought together the world's top experts to answer that very question. And their conclusion was really, really encouraging. The vast majority, 81% of those experts, believe we are largely prepared to handle this kind of threat. Now, are there still gaps to fill? Of course, but the foundation is solid. So here are the key takeaways. First, there are no known major asteroid threats to Earth for at least the next 100 years. Second, our ability to find and track them is getting better every single day. And third, and maybe most importantly, we have now proven that we have the technology to defend our planet. We aren't just sitting ducks, we are actively preparing.
We started this whole journey with a piece of viral misinformation. And it's pretty clear we have a solid scientific plan to deal with threats from outer space. But it does leave you with one final nagging question. How prepared are we for the misinformation that spreads so easily right here on Earth? It's definitely something to think about.